side A has a point charge plus Q located at each of the vertices. The electric field at the center of the cube you need to find out. So in this case, this plus Q and this plus Q, these are diagonally opposite, so they will cancel each other. The field due to them will cancel each other. This plus Q and this plus Q, those are diagonal opposite, so they will also cancel each other. And this plus Q and this plus Q are also diagonal opposite, so they will also cancel each other. So only remaining one will be which one? This one and this one. Now whatever the field for one will be the field for the others because they are having same value. So let's say this minus q have some sort of coordinate 0 comma 0 comma 0, and cube center has coordinate, and this cube center will have coordinate how much? The side are a, so this one will be a by 2 comma a by 2 comma a by 2. Okay, so you may write a by 2 I cap, a by 2 j cap, a by 2 k cap, and distance, this is r, or mod of r will be how much? A by 2 cube into 3, so this one will be your mod of r. A by 2 cube, a by 2 cube, a by 2 cube. Now you need to find out electric field. Electric field formula is, as this is minus q, so minus q will attract this one, so electric field will be in this direction, so you have to put a minus over here. Okay, and this plus q also repel the electric field plus q also will be in this direction, so whatever the value of minus q will be getting, you just need to multiply with 2 for the other plus q. So this is r. Now how to proceed? K q1 q2 by r cube, you know the formula, into r cap. R cap for the unit vector. Okay, so k q1 q2, not q1 q2, only electric field means k q by r cube. So for two charges there will be 2 kq by r cube, so 2 kq r cube is how much? This is 3 root 3 cube, so this is root 3 into a by 2, so root 3 cube is 3 root 3, and a by 2 cube is a cube by 8 into r cap. R cap means how much? There will be minus a by 2 x cap, a by 2 j cap, a by 2 k cap by root 3 a by 2. So this, or you can clearly write k by k cube r square into just r. So in that case you just no need to do this one. So in that case the calculation will be much easier. Root 3 square will be how much? 3. The formula is k cube r square into r cap. So for this r cap, you need to divide this r vector by root 3 a by 2. So you are getting a by 2, this one is cancel out, so x cap plus this is j cap is y cap plus z cap, this is minus 2 kq, so minus 2q 3 root 3 pi epsilon naught a square x cap y cap z cap. This is your correct answer. And you can without solving also you can say from this here, for two charges there will be 2, and for minus, because this is directed towards the origin, so these two term already cancel out for the sign, and as there is only minus q, that should be for single charge, so for two charge that will be minus 2q, that is why this answer is coming. Now the next question, this one is also a good question. Okay, you need to find out the electric field in the region between them. So this one is also sigma, and this is also sigma. So for this one, for any point, let's say this is a point, electric field will be in this direction. This direction means sigma by 2 epsilon naught into j cap. And for this one, this will in this direction, so you need to just make the component. This angle is 30 degree, so this one will be also 30 degree. If this is 30 degree, then this one will be 60 degree. So sigma by 2 epsilon naught cos 60 minus I cap, sigma by 2 epsilon naught sin 60 minus j cap. So the resultant field is sigma by 2 epsilon naught minus sigma by 2 epsilon naught sin 60 j cap cos 60 minus I cap. So sigma by 2 epsilon, you can take common, minus 1 minus root 3 by 2 j 1 by 2, that is minus I by 2. Option 4 is your answer. Okay, so this was also a good question. Now to the next question. This question number 90 is of a good concept, like motion of charge in an electric field. So in this question, there is y-axis, this is x-axis, and this distance is d, and the particle going in this direction. This x-axis, electric field is in this direction. That's all. Electric field is in minus j cap direction, and this is extend up to this. Up to this, electric field is extended. Beyond this, there is no electric field, and the particle is moving with velocity v naught. So as the electric field is in this direction, the particle will take a turn like this. The particle will take a turn like this, and then this will go in this way. So how to do this one? Let's say you need to find out the equation of the path in the region. So I am interested to find the position of the particle up to this position, up to this. So here the coordinate of x will be d, and y coordinate of the particle I need to find out. So for y coordinate, there is no any velocity component of velocity along y direction, so you may clearly write s is equal to ut plus half at square, u is 0, half at square for y direction. A is equal to qe by m, half q by m into t. The t should be replaced. X is equal to vt. Y, in the x direction there will be no force, so as there is no force, that will be uniform velocity. X is equal to ut plus half at square, there will be no a, so x is equal to v naught t, so t will be x by v naught square. So this is s is equal to q e. As the value of x is d for this one, that will be q e d square by 2m v naught square. So from this only you will be getting this coordinate. This coordinate as d comma q e d square by 2m v naught. Now after this line, this is a good question, because you need to find out the equation after this line. In sometimes they ask to find out the coordinate only. So after this line, up to this line, this will be having a parabolic motion. After this line, the motion will be straight line. As the motion will be straight line, the horizontal velocity should remain same, but the vertical velocity now will become, so as you got the distance, so vertical velocity will be how much? V square is equal to u square plus 2s. There is no u in the vertical direction. 2a is q by m, and s is q e d square by 2m v naught square. this is A, so 2 get cancel out, so V will be QE by M into D V naught. Now for this zone, let's say, now assume this is as the origin. So for, if this is the origin, then Vx into, sorry, V naught into T should be equal to X, and Vy into T should be equal to Y. So you are clearly getting Vy by V naught equal to Y by X. So Y equal to X into Vy by V naught. So this is Vy. So Vy is itself QE by D M V naught square, M V naught 1 by V naught into X. So you are getting Q by D M V naught square into X. Now this X is, now for this X you need to replace it. Replace by what? Because this is not the total X, this is not the total Y. So Y is how much? Y is this one plus this one. So in place of Y you may write Y plus D, Y plus QE by QED square by 2 mv naught, this 2 mv naught square. In place of Y you will write, so this is QED mv naught square X. So your answer will come minus QED mv naught square D by 2 minus X. Why minus? Because Y is in downward direction, that's why minus. So this will be your answer. So first you need to write the answer with respect to this one, then you need to shift the origin to this one, you will be getting this as the answer. Now this Y is, for this Y, this is, I have assumed Y from this zone. So if you need to assume from the actual origin, then this Y will be what? This will be D, this will be this QD by 2 mv naught square, this may be treated as Y naught, and this is Y. So you may clearly write that Y is equal to Y naught plus whatever the distance you will be getting. So Y plus Y naught is equal to this one, and from there you will be getting the answer, option B. Now next question. This question we already did in one of my video. Like, there is a dipole moment minus I minus 3j plus 2k into 10 to the minus 29 at the origin. So let's say the dipole moment direction at the origin is in this direction. I'm given the direction is this one into 10 to the minus 29. This is the direction of the dipole, and there is one r which is perpendicular to the dipole. So this is r which is perpendicular to the dipole. R is I plus 3j plus 5k. Now we need to find out, and given that r dot p is 0, so you need to find out the electric field due to this dipole. So for electric field due to this dipole, see, as this is a perpendicular point or equatorial point, so the electric field will be in opposite direction. So whatever the direction of the p will be, the electric field is just the reverse of the direction. So I plus 3j minus 2k will be the direction of the electric field. In this question, consider a sphere of radius r which carries a uniform charge density rho. If a sphere of radius r by 2 is cut out of it as shown, the ratio Ea by Ev of magnitude of electric field E and Ev respectively at point A and B due to the remaining portion. So consider a sphere. There is a sphere of radius r which carries a uniform charge r by 2. Density rho. As there is one more sphere. This is one more sphere which is radius r by 2. This is cut out from it. Then you need to find out the ratio Ea by Eb at point A and B due to this remaining portion. So there are 2 points A and B. This is point A and this is point B. So at point A, electric field due to this whole sphere will be 0. because that is the center of the sphere. And for this portion, that will be how much? K into Q. Okay, Q will be how much? If this is total charge is, for this total charge is Q, as this is uniform charge density, so for R 4 by 3 pi r Q volume, the charge is Q. So for 4 by 3 pi R by 2 Q volume, the charge will be how much? Q by 8. So for this one, the charge will be Q by 8. So in this case, what will happen? You first need to find out the electric field for point A. I am saying for point A, you first need to find out the electric field of the total sphere at point A, that will be 0. And for this sphere at point A, that will be K into Q by Q will be how much? Q by 8 by R square, because this point is on the boundary of this sphere. So this will be the net sphere at EA. And for EB, that is electric field at this point, for this total sphere, electric field at this point will be how much? K into Q by R square. Now for this sphere, this total distance is how much? R plus R by 2, that is 3R by 2. This one will be this much. So now we need to find out the ratio. KQ is common, so this total value is KQ. Let's say KQ is some constant C. Then you are getting this is C by 2, and for this one 1 by R, C by R square minus C by 8, 9 by 4. So you are getting C by 18. So from there you are getting 17 C by 18. So if you do the ratio C by 2 by 17 C by 18, you are getting 18 by 34 as your answer. In this question, there is an electric dipole formed by two equal and opposite charge Q and minus Q with separation D. The charges have same mass M. It is kept in an uniform electric field E. So if it is slightly rotated from the equilibrium orientation, then it's angular frequency. So you well know that when it is rotated from the angular, which let's say this in this direction there is P. So tau is equal to P sine theta. Sin theta is very small, so you can write this as theta, and tau equal to I alpha equal to P theta. So I will be, if this is D, this one will be D by 2. So m into R square, m into D by 2 square into 2 into alpha equal to PE into theta. And for P you may write Q into D. So in this case you are getting QDE into 2 by md square into theta. So this is your omega square. Omega will be how much? Over 2QE by md. That will be your omega. Now to the next question. Uniform electric field of magnitude 100 volt per meter in space is directed along line y equal to 3 plus x. You need to find out the potential difference. Y is equal to 3 plus x. So this will be a line. Y is equal to mx plus c. Here c is 3 and m is 1. So you may clearly write y minus x is equal to 3. So y by 3 minus x by 3 equal to 1, or this as like this. So this is the slope intercept form. So this point will be 0 comma 3 and this point will be minus 3 comma 0. This is x, y and x axis. Find the potential difference between point 3 1 and 1 3. So 3 1 will be a point So this is the direction of the electric field. 3, 1 will be this point, and 1, 3 will be this point. So now if you find out the slope of this line slope is tan theta is 3 by 3, 45 degree. Now 3, 1 and 1, 3, if you find out the slope of this one, 3, 1 and 1, 3, these 2 points, then also you are getting tan theta that equal to 45 degree. Sorry, 1, 3 point will be at this position. Let's say this one will be 1, 3 and this point will be 3, 1. So if you find out the slope, tan theta should be equal to -1, and for this one tan theta, for this line tan theta is equal to 1. So as if you multiply the slope, you are getting that that is -1, m1 into m2 is equal to -1. So that means the line should be perpendicular to each other. So this line should be perpendicular to each other. Now electric field for this line will also be perpendicular to this line. Electric field is how much? Let's say this is 100 volt per meter. E equal to d by. Now you may write Ex equal to minus dV by dx. Ex will minus dV by dx. For minus dV, so let's assume you are getting from going from this point to origin. We are going from this line to origin. So dV is how much? Let's say this is 100 volt per meter. So for this line, let's say the electric field will be 0. So this, just find out this one. This one is how much? If this is 3, this is 3. So this is 45 degree. So this will be how much? 3 by root 2. Okay. I did a big mistake because the electric field direction is given this only 100 volt per meter. So if this is the electric field direction, it is well known to us that the potential line will be perpendicular to this electric field, and this line is being perpendicular to this electric field. So in this line, I just no need to solve this one, anything, nothing should be solved. In this line, the potential of all points should be same, because this line is perpendicular to the electric field. So any line which is perpendicular to the electric field is equipotential line. So this line is equipotential line, so potential at this point will be same, so the potential difference will be 0. So in the first case, what I means by mistakenly what I was doing, that I was taking this as one potential line, that is 100 volt, and I was assuming that this to be 0 volt, but in the question this is given that this is 100 volt per meter. That means the electric field line is given in this direction, so potential line will be along this direction, and at all point the potential will be same. Okay, now for the next question. So in this question, there is a neutral metal sphere of radius r is connected to earth through a switch S, which is initially open. Two charges plus 3q and plus 2q are kept at 9r, plus 3q plus 2q kept at 9r and 3r. This is 9r and this is 3r. Now when the switch is closed, the charge flown from the sphere to the earth. Okay, so let's assume initially there was no charge, this was neutral, so let the charge is q dash at initial condition. At initial condition there is no charge. Whenever you are connecting this one, let the charge is q dash. So if the charge is q dash, so for this 3q, the potential on the sphere will. So you can easily write k into 3q by 9r, because potential due to this one at this point, potential due to this one at this point will be kq by k into 2q by 3r, and potential, let's assume for the connection of switch, it is getting a charge q dash. So potential due to that q dash is kq dash by r. So we can easily write q dash equal to 3 by 9 plus 2 by 3 q, 1 by 3 q, that is minus q, q is equal minus q. So this is getting a charge minus q. So this sphere will get a charge minus q. Now next question. So in this question there is a charge q at some distance from the center, and you need to find out which of the given statement is wrong. So if this is q, so the inside of this sphere will get a charge minus q. Okay, so and outside will be getting a charge q, and due to this q, a minus q will act on here at here, and this minus q will be distributed uniformly throughout, and due to this minus q, a plus q charge will be distributed in the sphere in outside direction uniformly throughout. So the fourth option, potential at the inner surface and outer surface of the conductor is same, because inside the conductor electric field is 0. So at this point and this point, as E is 0, E is equal to minus d by dr, dv should be constant. So potential at these two surface should be constant, because E is 0, because if you take a Gaussian surface, as I discussed in the earlier question, then within this Gaussian surface net charge is 0, so E will be 0, so dv 0, v should be constant. As v is constant, then the third option, non-uniform distribution of charge, I already said that charge will uniformly distributed due to induction. Option 2, outside the conducting sphere radial electric field will exist. Obviously outside this sphere, if you see, net charge is q minus q plus q, so obviously radial electric field will exist. And the last one is, there exists radial electric field line in empty space. Within a hollow sphere, always the electric field will be 0, because if you take this as a surface, then within this Gaussian surface net field is 0. In case of gravitation, that doesn't happen. In case of gravitation, you will be getting a field, but in electrostatic, the net field inside this will be 0. So this was some good questions from electrostatics, and then I will be solving, in the next lecture I will be solving few questions of current, electricity and induction.